Hello, Chem 20s. Our review lesson today is going to be on atomic basics. When working with the model of an atom for Chemistry 20, we are going to be concentrating on the values we get from our periodic table to look at protons, neutrons, electrons, and those distinct energy levels that we will find, electrons. If we think about the atomic number, a reminder that each element on the periodic table has a distinctive atomic number as you go across the table. The atomic number represents the numbers of protons contained in the nucleus of an atom. The protons, however, are positively charged particles found in that nucleus. So the might be what we want to call the symbol for a proton would be P positive. Well, if protons are found in the nucleus of an atom, electrons are found in the space around an atom. These would be found in energy levels or orbits or shells surrounding the nucleus. They are negatively charged particles and they get the symbol E minus. So let's take a look at our periodic table and find argon. You will notice that argon is element number 18 on your periodic table. So I have drawn a nucleus. Inside the nucleus for argon, since argon is element number 18, that means it has 18 protons. That also means it's going to have 18 electrons surrounding it. So there are going to be 18 electrons floating around out here in these shells. An easy way to remember all of this would be for us to write this down. Now, in Mr. Kemp's class, when you have to memorize something, he puts it into a box. So, for an atom, and I'm going to be very firm on this, for an atom, we are not talking ions. For an atom, the atomic number is equal to the number of protons. For an atom, the number of protons is equal to the number of electrons. So for argon atom, because argon is element number 18, or the atomic number is 18, it will have 18 protons in the nucleus. It will have 18 electrons flowing around the nucleus in orbits or shells or energy levels. Now, most of us realized when I drew it on the last page that that was not the correct way to draw the electrons, because the electrons have a maximum number per shell. So in the first energy level or first shell, it can only hold a maximum of 2 electrons. The second energy level can only hold a maximum of 8 electrons. The third energy level as well can only hold a maximum of 8 energy levels. If you think about your periodic table tells you this, because if you look at the periodic table, take a look at how many elements are in period 1. Hydrogen, helium, 2 elements, 2 electrons in the first energy level. In period 2, you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. You have 8 elements on period 2. You get 8 electrons in the second energy level. In the third period, again, if you do a quick count, you can have 8 elements, which means 8 electrons in the third. After that, we assume that all higher energy levels hold a maximum of 8. It's more complicated than that, but we're going to keep to the basics here. We are never going to draw something past element 20 anyways for a picture, so calcium is going to be our limit. We want to keep to only representative elements. If we move to element 21 for a drawing, we would now be in the transition elements, and we are not going to do that. Also, a reminder of a word you should know. Valence electrons are electrons that are in the highest energy level. So the number of electrons in the highest energy level, that is your valence electrons. So I've got a picture here, a diagram. If I take a look, it looks like we have 2 electrons, 8 electrons, 8 electrons. So we've got a total of 3 energy levels. So that means we are going to be in period 3. We also, in our valence electrons, have 8, so it's full. So we would have and say that this element is argon, the example we've been doing. How many valence electrons are there? Well, if there's 8 in the outer shell, the answer would be there's 8 valence electrons. And what family does this element belong to? Since it's in group 18, we know that this is a noble gas. So this is a good example of going back and reviewing some of the stuff that we should have picked up on previous videos. So let's look at some more definitions. Now, what I want to do is we're doing argon as our example still. So I'm going to put this here. We know argon is element number 18, so it's got 18 protons. And we know it's argon, so it's got 18 electrons floating out here, we said. But remember, we can do better than that. We now know the maximum that can go in each shell. So if I have to place 18 electrons, because the number of protons equals the number of electrons in an atom, we're going to place 18. Well, 2 electrons are in the first shell. 8 electrons are in the second shell, so that's 10, and that leaves us 8 electrons in the third shell. It is perfectly filled. The reason it's perfectly filled is because argon is a noble gas. Noble gases are inert. They have full energy levels. They are the kings and queens of the periodic table, which means they are also kind of boring. They don't want to react because they are already perfect. So what is a neutron? Because we know protons are in the nucleus, electrons are in orbits outside the nucleus. Protons are uncharged particles. We would give them the symbol N0, found in the nucleus of an atom. So we already know neutrons are going to be found in the nucleus here. The question is, how do I determine how many neutrons argon atom will have? Well, we're going to need the atomic mass for that. Now, the atomic mass is the sum of the average number of protons and neutrons in an atom. We use that to describe which isotope of argon we're talking about. What you need to do to solve for this is round the periodic table atomic molar mass value to find the mass number of the most common isotope. So, looking up argon, the mass number is 39.95, which means let's round it up from 39.95 to 40. Your protons and your neutrons should add together to equal that rounded mass number. So 18 plus what gets me 40? So for argon atom, that's going to be 22 neutrons. 18 plus 22 is 40, so I have 22 neutrons. When we're looking at the mass over here, the 40 or the 39.95, I'd like to point out that electrons play no role in that mass because electrons are so small, we almost consider them inconsequential. So what I'm going to do is I had another rule in a box, and remember, boxes in my class means you memorize. How do I figure out the number of neutrons? We'll take your protons and your neutrons, and they need to add together to equal your rounded atomic mass number. And again, I would be content if you wrote in here your rounded atomic mass number. So pretty straightforward. Now, we've used the word isotope. An isotope is when a substance, for example, carbon-12 here, compared to carbon-14, what's the difference between the two? Well, I'm going to draw this. This is going to be carbon, and we're going to call this 12. And then this is going to be carbon, and we're going to call this one carbon-14. Now, this number here stands for what the atomic mass will be. So carbon-12, we know we're looking at a mass of 12, or in our case, if you check your periodic table, 12.01. There's also an isotope of carbon, which is carbon-14. This is the stable isotope off the periodic table that we know. This is the unstable isotope over here, the one that's a little bit more dangerous. Well, let's go ahead and draw the stable one for carbon-12 first, and then we'll talk about carbon-14. So we know that carbon is element number 6, therefore it has 6 protons. Regardless if it's carbon 12 or carbon 14, it's still going to have 6 protons on a carbon atom. Since it's 6 protons, it's also going to have 6 electrons. 2 electrons in the first shell, 4 in the second shell adds to 6. That is also going to be true for carbon 14. 2 electrons in the first shell, 4 electrons in the second shell. What changes is in an isotope is the number of neutrons. Since this is carbon 12, we know the mass number was 12. So 6 plus what is 12? So carbon's going to have 6 neutrons. Because this was carbon 14, that means the mass number was larger. This is the unstable form of carbon. So 6 plus what is 14? This one's going to be 8 neutrons. Now, the question is, why are there isotopes? Well, if you take a look on the periodic table, carbon has a mass number of 12.01 grams per 1 mole. So if I think of this kind of as a different example, think of this as I have 1 million carbon atoms. You'll notice that the molar mass is very close to 12. That means out of 1 million carbon atoms, almost every single one has a perfect number of protons and neutrons. They're almost perfect to have 6 protons, 6 neutrons. They're going to be normal over here, everyday standard carbon. And so they're going to add up to 12. The problem is out of about every million carbon atoms, 1 out of 1 million are going to be a carbon 14, which means when they add together their masses, this one's going to be a little bit bigger because it's carbon 14. So about 1 out of 1 million is going to be a little bit bigger. So the average can't be exactly 12 anymore. It's going to be slightly higher at 12.01. That's where we get the mass number from. That's why our mass number is not exact. You will notice that there are many numbers on the periodic table that are very, very close to a whole number. Carbon 12.01, hydrogen 1.01, nitrogen 14.01. And then we also have some that are dead on, which means they don't have isotopes. So something like helium is exactly 4.00. There are no isotopes of helium. Something like fluorine is exactly 19.00. There are no isotopes for fluorine. Now, is it possible that something is a little bit lower as well? Certainly. That just means that their isotope might be a low number, and 1 out of 1 million might be, let's say, what would be something that's low? I'm looking here. Well, phosphorus is 30.97, so almost 31. Means 1 or 2 out of 1 million phosphorus molecules, instead of being adds up the protons and the neutrons to 31, they would add up to 30 instead. And that's going to bring the average down that little bit. So in an isotope, the difference has nothing to do with the electrons. It has nothing to do with the protons. It has everything to do with the number of neutrons in the nucleus of an atom. Okay, what I would like you to do is pause the video or watch one more with me for drawing an energy level diagram for an atom. Then pause the video and try drawing the other ones for yourself, and unpause the video when it's time to check your work. So let's find sodium. Sodium is element number 11 on the periodic table, so that means it has 11 protons, which means it's going to have 11 electrons. 2 in the first shell, 8 in the second shell, 1 in the third shell. Since it's got a mass number of 22.99, it's going to round to 23. 11 plus what is 23? That's going to be 12 neutrons. This is true only for sodium atoms. It's going to be key. I'm going to keep writing it down because I want us to make a distinction for atoms. Please try oxygen and helium. So oxygen is element number 8, so it's got 8 protons in the nucleus. Since it has 8 protons for an atom, it's also going to have 8 electrons, 2 in the first shell, 6 in the second shell. Again, the rounded mass number, or the mass number exactly for oxygen, is 16. So 8 plus what is 16? Going to be 8. plus 8 to 16, so 8 neutrons. Again, let's look at oxygen for a second. It's got 2 energy levels, therefore it's in period 2 on your periodic table. Its valence electrons is a 6, so like for all representative elements, in groups 1, 2, 13 through 18, drop the 1 in front if you're in group 13, 14, 15, 16, 17, or 18. And so because it's in group 6, we know it was going to have 6 valence electrons. And again, let's do helium. Helium is element number 2, so that's 2 protons, which means we have 2 electrons to fit. And it's got a mass number of 4, so 2 plus what is 4? That's going to be 2 neutrons. You'll notice its valence electrons is 2. It's got an outer shell. It's full. Of course it's full. It's a noble gas. It's boring. It's not going to want to gain or lose electrons given its noble gas configuration. Well, another way to think of this is without drawing pictures, let's see if we can fill in this chart. So I've given you some certain gaps to fill in, and I've given you enough clues that you should be able to do it. So let's do the first one. We have sulfur atom. All these are going to be atoms. So the atomic number of sulfur is going to be 16. If it's atomic number 16, that means it has 16 protons, which means it also has 16 electrons, because in an atom, these guys equal each other, cancel out. Now, the mass number when I look it up for sulfur is 32.07. So I'm going to write down the full mass number, and we're going to round this to the nearest whole number, 32. So protons plus neutrons equals mass number. So 16 plus what equals 32? Gonna be 16. 16 protons plus 16 neutrons equals 32 mass number. Okay, again, if it was me, pause the video, try the next 4 for yourself, unpause the video when it's time to check your work. So copper is element number 29, which means copper atom has 29 protons, 29 electrons, and when I look up the mass number, it's 63.55. So protons plus neutrons equals rounded number, which is 64. 29 plus what equals 64? That is going to be 25 neutrons. You'll notice I'm just starting to put the symbols in, just getting you used to it. Well, we have a mass number here of 44.96, so we're going to look on our periodic table. 44.96 is scandium atom. So this is scandium. Scandium is element number 21. Therefore, it's got 21 protons, 21 electrons. 21 plus what equals 45? And our answer is going to be 24 neutrons. Again, atomic number 53. Number 53 is going to be iodine. Iodine has a mass number of 126.90. Well, if it's got an atomic number of 53, that means it has 53 protons. If it's got 53 protons in an atom, it has 53 electrons in an atom. 53 protons plus what equals 127 rounded mass number? And I believe that is 74 neutrons. So you can see the protons and the neutrons can equal each other. They can be lower, they can be higher. There is no rule for neutrons other than protons plus neutrons equals the rounded mass number. So last but not least for an atom, if we have 50 protons, we will also have 50 electrons. If we have 50 protons, that also means our atomic number is 50. So element number 50 on our table is tin, Sn. The mass number of tin is 118.71, so that rounds to 119. 50 plus what is 119? And I believe that is 69 neutrons.